So good afternoon, my name is John Nicholson, Senior Technical Marketing Architect in Storage and Availability Business Unit. It's a really long mouthful of words there. You can find me on Twitter at lost_signal. This is the session vSAN 661, What's New Technical Deep Dive. So hopefully everyone's here for that. We've got the standard disclaimer, and we're going to move quickly on. So just quick level set. Hyperconverged is the fastest growing segment within storage and infrastructure. We've got a long way to go in terms of adoption, but it's been moving very quickly. From a positioning basis, vSAN is delivering a great solution that fits nicely between cloud storage, in the back end, as well as traditional storage. It's still going to be around for a while, but often is very costly and complex. How many of you are using vSAN today? Show of hands. All right, so we're just going to skip a bit. Use cases were all over the place. By the way, 10,000 customers now, so you've got a lot of friends, and it's growing rapidly. We just announced our 7th quarter of 150% year-over-year growth. And getting into the release cadence, one thing just before we get actually into the raw technical details, we've had a lot of releases, and we've been releasing about twice a year. And from a cadence and capabilities, there's been major focuses. 6.6.1 was really modernizing infrastructure, and there's some kind of themes that go into that. And then going into 6.6.1, we've got kind of these 4 different buckets that we're trying to label the features and how they go into. Now, there's going to be a quiz on this slide at the end, so I want everyone to pay attention. I like using this slide because it's kind of hard to read. But it shows the cadence again that shipping twice a year, a lot of incredible features. It also shows that the 6.6 release, which 6.6.1 is not even on here, it doesn't fit, unfortunately. We're picking up the pace. We're continuing to deliver innovation, and going from our original product. Anyone remember the tagline for vSAN 5.5? It was radically simple. The product is still simple to use, simple to consume, but we've kind of ditched that. It's a powerful product. So in environments, we want to make sure that you can, as you grow your virtual environment, you continue to ingest more enterprise and different workloads. And some of this is, having native capabilities for controlling risk. We also have to control not only risk, but costs and environments. And so we're always looking for ways to provide more efficiency into an environment. And then from a growth perspective, we want to make sure you're able to scale with the new kinds of applications and demands that are being put on your data center. So the first one of this is talking about controlling risk. Big request has come out for encryption previously. And engineering looked at a couple different ways to do this. One of this was the easy button, which I like to say we take the hard route a lot of times, but it's generally the best route. We could have used just traditional self-encrypting drives. You grab them off the shelf. The challenge with that's additional HCL testing. The other thing is if you look at self-encrypting drives, they often cost more, typically about 20–30%. And the newest generation of drives and the newest generations of NAND typically are not necessarily there or qualified for that use. So you're potentially holding yourself back from getting just raw power and performance and capabilities. The other thing is we didn't want to put customers in a situation who maybe already invested with us. We've got a lot of existing customers in the room today. We wanted this to be something that you could enable in your existing environments and be able to use your existing hardware. So looking at this, we took a very unique approach. This vSAN encryption is done at a software level. We're using AES offload functionality that's native to modern Intel and AMD processors. This stuff's actually really good. From a latency overhead, very low input, as well as CPU, very controllable. And so this is something that's enabled at the cluster level. So when you're setting up vSAN, you check the box for DDoS compression. There's another checkbox for encryption. You're done. Point at your KMS servers you've set up. For key management, we're using external KMIP compliant key managers. We've got an HCL for this. We've done our own testing. It works with all the major providers. Reach out to your key management provider today to talk to them about that. So under the hood, how this works, because one thing that's unique with this versus traditional encrypting in guest or even VM encrypt, the VIO filter, which are your other options, those solutions are great, but they break deduplication and compression. If you're encrypting at a higher level, you're now having this data that's unrecognizable. It's not going to be able to fingerprint or dedupe, particularly if there's different keys. And compression doesn't work well on high entropy data, which is what encryption fundamentally is. So how do we solve this problem while maintaining full data at rest encryption? So vSAN, as you know, it's got a 2-tier architecture. We've got our, particularly in a flash or hybrid, we've got our write buffer, drive, our cache device, and then you've got your capacity device backing it. As the data comes in, it's encrypted, and it's written there. So it's encrypted before it's written. Now when we go to D-stage, to that lower cost capacity device that's backing it, that's when we run our deduplication compression. So we do a decryption, we analyze that for duplicate data compression, SHA-1 for the hash identification, LZ4 for the compression, and then we re-encrypt. And so by doing this process and having the encryption just be part of the I/O workflow, one, we're not doing any additional write amplification here, but we're also making sure that we can leverage deduping compression to its fullest while doing encryption and meeting our compliance requirements for data at rest. Now, another thing that's come up is how many of you, you manage your environments, you're using vCenter typically day to day for most management. We've got APIs, we've got other things, we've got CLIs, but vCenter is a key important thing. And so you want to, in a situation, that vCenter's down, it's having some issue, it's under maintenance, you still want to be able to manage and monitor your environment. So I believe it was 6.0 update 3, the vSphere team released a native HTML5 client that actually lets you manage hosts directly without the use of any plugins. It's great, no Flash required. Anyone like Flash? No, I get a chuckle. That's always a good cheap shot. So from this standpoint, we've added the ability to monitor vSAN and be able also to make basic configuration here. And you've got visibility into the environment, and you can consume those health checks and things that are running actually independently of vCenter. We also have CLI that you can run directly against a host and do a full health check across the cluster, and you can also call it by API. So having more standalone manageability for customers, it's, even in the worst case, you still have visibility into what's going on. Rebuilds and resynchronization. Now, vSAN, it's a distributed storage system. There's obviously, as you add more data, as you maybe have a host or capacity device fail, you've got data that needs to be rebalanced in that environment. As new data is coming in, you add new nodes and things like that. We're constantly been tuning the placement algorithms that LSOM, our logical storage object management system, uses in terms of placement. But we've had customers ask for more visibility and control. So by default, we try to be fairly aggressive in terms of resyncing that data, just because we don't want you to be exposed. But we may have customers who they want to prioritize the production workload access at a higher level than the defaults are. So there's actually a slider bar. You can adjust that, and it now exposes, and you can monitor in real time the throughput of those. Previously you could see that things were rebuilding, but we've got a lot more visibility there, as well as also a lot more control that's capable in terms of that. The other thing is how we do rebuilds has changed. So previously, rebuilds were really based around the object model. So quick, refresher here, vSAN's an object storage system. If you've got a RAID 1 policy attached to a VM, it's going to have 2 copies, an object. Now that object may have multiple components below it. They make up the objects based on stripe, or if it's chunked out from a large size. The challenge was if an object became damaged, one of the 2 mirrors became damaged, it lost one of its components or one piece, it would rebuild the entire thing. Now we rebuild at a component level. So we're much more granular. This can lead to much less synchronization of data. So we're also looking in terms of speed of resynchronization. Again, we've done a lot of things on the back end to improve that capability and just general write speed of the underlying platform. And this is actually helping quite a bit. There's actually a good white paper on storagehub.vmware.com that talks about some of the new performance improvements that came in with 6.6. So looking at an example, we also have a system now that we can do what's called a partial repair. So this example is a fun one. We're using what's called failure to tolerate of 2. So and we're using RAID 1 for our protection. You obviously could use RAID 6, but in this case we're going to use mirroring for the example so I can talk through it. So this makes 3 copies of data. It also, for quorum and preventing split brains, you actually get 2 witness components. That way you always want an odd number for voting. That's how this works. It automatically generates it. So in this example, we lose 2 out of the 3 copies of data. We're still available at this point, but our effective compliance is we cannot tolerate another failure. We're at failure to tolerate a 0, effectively. So we need 5 hosts in order to be able to have 3 copies of data and 2 witnesses. So now that we only have 4 hosts, we don't have enough to fully protect and get to FTT at 2. So what we're going to do now is we're going to make a best effort. to try to restore availability with the resources we have. So in this case, we're going to replace one of those witness components with a replica, as well as use another one of the remaining hosts so we can get back to having 3 copies of data. Now our effective compliance, because we have 4 hosts, we can only tolerate 1 failure that's simultaneous, because we only have 1 witness. We need the second for voting to get back to an odd number. But we're still making a best effort in this regard. And the thing is with the environment is, let's say we get one of those 2 hosts that failed back online, it'll go ahead and put that witness there and restore us back to FTP2. So vSAN under the hood is fighting to protect your availability, protect the integrity of your data, and we're increasingly focused on making these algorithms smarter and more efficient. Now another thing about failures and failure modes is, I learned this a long time ago when I was building storage systems in my home lab and things like that, is you learn, failure is not always binary. Things don't just always drive. Sometimes they get slow. Sometimes they get weird. And particularly one thing we notice, particularly with flash devices, a lot of times they don't die just outright, but the warning signs start coming. Performance gets incredibly erratic. The other challenge is when you start trying to do predictive failure, say, oh, if latency's high, shoot that drive in the head. Well, the problem is some of these devices, particularly the ones that aren't rated for high endurance or capacity devices, when they're doing garbage collection, write latencies will spike. It's partly the way I do a 2-tier vSAN design. Those write intensive, those higher endurance drives, they have a better write latency consistency. We're protecting you from the erratic latencies of backend capacity. So how do you know it's not just a brief problem and this is an extended problem? This drive's never going to return to being performant. So we've got people who have gone through the analytics of this, and we've looked at a lot of different scenarios. We have multiple dynamic windows. So we'll have a sliding window of several hours, and through that, every 5 minutes, different devices are pulled, and we spread that out even further just to make sure it's not a particular thing tied to time of day, or it's not just one coherent band. We want to make sure that we know this is a consistently bad device before we proactively fail it. And so, again, it's a lot smarter people than myself who are working on this. But what's really cool with this is that a lot of systems, they work on a very binary. They'll just let that device perform poorly and impact the environment until it truly dies. Or worse, they'll just start shooting drives in the head who just have a general brief burst of latency. And if your whole environment's made out of those, you start shooting all the drives basically from a failure mode. That's even worse. So this prevents both of those situations from happening. And how we do this has gotten impressively better, is that we'll look at the drive and say, all right, we're flagging this one for removal. We're about to shoot it, but is it the last known good copy of any data? If it's the last known good copy of data, we're going to keep it alive and try to pull that data off of it. Now, if there's other good copies of data, we're done with it. We're going to quit sending I/O at it. Because trying to rebuild from a device that takes 500 milliseconds or 2 seconds to get data out of, that's probably just going to drag out the resync operation versus using the other copy of data. So, again, under the hood, we're working to make this environment more resilient. Another thing also is operations, exposing more information, making you more aware of what's going on. This is something that we've really got to help make our customers be able to have more awareness of when they do things, what the impact of that is. So, and this is something that carries over from a challenge from traditional storage arrays. When people are looking at making changes in environment, they're evacuating hosts, they're evacuating disk groups, maybe they're changing a policy, or they're configuring a policy. You need to know what the impact of that is. Because if you're making a change that's going to impact 10 gigabytes of data, fine, let's do that in the middle of the day. Who cares? If you're about to make a policy change or evacuate a host and it's going to send 80 terabytes of data flying across the network, you probably want to know that before someone yells YOLO in the data center and mashes, evacuate that host. Everyone's got that ops guy who's got, kind of that cowboy attitude of it reminds me, what was it, Dr. Strangelove, the guy who's writing the bomb, he's screaming, yeehaw! It's like, let's do this, let's see what happens. We got to rein those cowboys in and operations, and part of that, though, is providing visibility to understand the impact of what you're going to do. And this was a challenge even on traditional arrays. In many of my own personal experience, I remember doing large-scale migrations could sometimes bring down 80% of the performance of an array. This isn't a unique challenge to HCI, but by exposing this into the UI as well as making this available by API, this helps you understand what you're doing, so to speak, from a management standpoint. So driving down cost at scale is another one of the key buckets that I mentioned. So vSAN stretch clustering. Anyone running vSAN stretch clustering today? Okay, we got a couple. So the first version was good. It worked, and it's radically lower cost than traditional stretch clustering solutions. It's also a true active solution. It is synchronously writing writes to both sides, and you can pull data from both, and so you can vMotion a VM back and forth. This isn't just spewing data on the wire and calling it a day. This is a true stretch cluster. That word gets abused sometimes. So one of the challenges, though, is that the stretch clustering was just a basic RAID 1 between the two sites. All you had was mirroring between the sites, and that's it. So if you completely lose one site, you're available on the other side, HA works, you fire off, you reboot your VMs, but you're now basically RAID 0 at that site. And there were some things you could try to, deconvert that from a stretch cluster, but if you're in a situation where you know that other data center is going to be a smoking hole in the ground for 3 months, or a giant lake like my current hometown, you probably wanted to be able to have the ability to tolerate some failures even after you've lost a whole site. And increasingly, I talk to customers as more and more mission critical workloads are virtualized and deployed. I've heard the phrase, if this goes down, people will die, way too much lately. And so being able to tolerate consecutive failures in your environment is really critical. So we now have the ability to set a local RAID protection. So you can have locally RAID 5, RAID 6, distribute RAID 1, multi-way mirroring, and then also do mirroring between the sites. And how this is controlled is through the storage policy engine. So if we look here, we have, previously you just would have had failures to tolerate. Now because it's a stretch cluster, we have a primary failures to tolerate, which is 1. That means we're going to mirror. If we set it to 0, then that means we only keep it on one side, which I'll get to in a minute. The other option is we've got the secondary failures to tolerate. In this case, it's set to 2, and then we've chosen a protection method for that secondary failure of RAID 5, RAID 6. Since it's 2, we'll get a RAID 6 within that site. So we can tolerate a lot of failures. In fact, you can pretty quickly develop environments and situations where you can lose 75% of your hosts across both sites and still keep operating. Now, what about, though, I've got some systems that I don't want to replicate. Maybe I've got test dev I don't care about, or maybe I've got applications that replicate themselves. Domain controllers. Do you really need to replicate them if they, obviously Active Directory's replicated itself for years. SQL, Oracle, if you're running Oracle Data Guard, where Oracle's replicating itself. Maybe you're handling that at the application level and you don't want to replicate data that's already replicated. You can only have so many layers of ridiculous redundancy. So in that case, you could have a separate policy where you set that failures to tolerate to 0 for the primary and then still locally protect it. So you could have a mixed environment of different, based on SLAs for availability or capabilities of where application level failover and things like that are handled in the same environment. We're not forcing you to have one choice of RAID or protection across everything. In fact, because this policy engine can be dialed down to individual virtual machines and again, individual VMDKs, this gives you a lot of different flexibility in terms of configuration. And I love the storage policy engine because this is actually consumable at a higher level through a lot of different cloud management products. So if you're running vCloud Director, vRealize Automation, View will automatically create policies. vSphere integrated OpenStack. We have OpenStack integration for SPBM. And so being able to consume that at a higher level, it helps you both automate while still keep those applications, get them the policy and compliance they need. We talk about, as a company, the software-defined data center. I like to call it in some ways the policy-defined data center. Because if you look at what our friends with NSX are doing with security policies, availability of network, we're doing the same thing in terms of delivering security, availability, performance, and other characteristics for storage here. And then giving you multiple options in terms of higher level ways to consume and automate that. From an operations side, we now have the ability to be able to redeploy the witness from within the UI. We've had some things previously where the CLI are required manual intervention. And so we're trying to make it so the environment is a lot more consumable and simple for operations and the higher staff. Makes stuff much easier to manage. Now, this is a slide that I expected, probably just to, have a microphone drop it and walk out and enjoy the applause. Because how many of you like multicast? Do we have any network engineers in here? Okay, good, not too many. They're the worst. Multicast at layer 2 actually wasn't that bad. It really wasn't. It was generally 1 or 2 commands on a switch. I was going to say, now, when you got into multicast at layer 3, you started doing leaf-spine vSAN designs or stretch clustering over layer 3 circuits. There'd be dragons in routing multicast. There really were. And even then, that 1 or 2 commands, it was different on many different switch. People, if you're in a large organization to where communication between teams, change control, touching the switching fabric in a production environment, that could slow down deployments. And we want to go fast. We want you to be spinning up vSAN clusters quickly and easily. So we have switched to unicast. So to peel back kind of under the hood why we chose multicast originally, it's actually not what everyone thinks. Everyone thinks it was about throughput, would be the assumption. That actually wasn't it. It was for speed and efficiency of CPU consumption in the object system in terms of pushing out updates. In the case of a large-scale failure or node reconvergence, it was actually very efficient at that. Our engineers did a lot of really hard work to make that CPU efficient under unicast, so the performance overhead and the time overhead was non-impacted. One of the other things also multicast was used for was for node discovery. We could have used broadcasts, but the problem with broadcasts is they don't work beyond layer 2 unless you do some really non-standard, unnatural things in your switching environment. I'm looking at the networking guy for a nod. So node discovery is handled differently now. So your vCenter will act as a primary source of truth in terms of notifying hosts of where their friends are. Again, vSAN is a distributed system. The vCenter, there's a management plane, but it's not a platform of state. It doesn't, the actual membership directory services, those are distributed. Every host is running them. We don't have a central metadata structure. There's metadata stored copies on every host. And so the vCenter, as you add hosts to a vSAN cluster, it's going to notify the various vSAN nodes, here are your new friends. Now, starting in 6.6.1, if that ever gets out of sync in any way, having vCenter as a source of truth could actually cause some issues. So in the first version, in 6.6, when this originally came out, we did have some challenges in that if you ever restored a vCenter from a previous version or state, it would potentially go update and push out a bad list that might be missing some nodes and kick some nodes out, which could be bad. The other issue is if you had a vCenter case where you were just deploying a new vCenter to an existing cluster, it's going to have a blank slate, and that's going to potentially have issues as you add hosts back in. So to solve this in 6.6.1, we have a system where the vCenter is the primary source of truth unless it sees that it's out of sequence with the host. There's a continual host sequence number. If it is, you'll actually get an alarm. And what you do here is you add all the hosts back into vCenter, and then there's a vSAN health check, and you go push that button and say, go reestablish sync. And this will prevent it from any way from automatically dropping hosts or causing any issues. So this is how we got through the challenge of how to do discovery, do it across layer 3, and do it in a safe way that makes it easy but doesn't create some type of single point of failure for the environment. So, helps. So analytics. We've got a couple different pieces to analytics, and again, I encourage everyone, if you really want to see the future of what we're doing with cloud analytics and vSAN, go find Christian Dickman and Junchi's session in the calendar. I think it's on Wednesday. One of the first things we did is we've had a challenge. So vSAN Health Check is a great tool. It provides insight into your environment of potential things that need to be fixed. And this came out originally with 6.0 update 1. It was a little spammy. We've trimmed that back quite a lot. It's a lot better and a lot more directed. And as this has evolved, one of the challenges we have is if we've got a customer who's on 6.0 patch 3, there are new health checks that have come out in the new version. But if he hasn't updated yet, he's inversely not aware of the issues that may impact him. And unfortunately, you have this chicken egg problem of the customer most likely to be impacted by a known issue is the customer running the oldest code, who's going to have the fewest number of health checks. So we now have the ability, starting in 6.6, to dynamically deliver health checks. So your environment, as long as customer experience improvement program is on, which is by default, it's going to phone home every hour and look for new health checks. And if there's new health checks in the environment, it's going to pull them down into your environment, look through your environment, see if they're relevant. And if they are, it's going to notify you and say, hey, here's a known issue, here's the KB, here's the resolution steps for this. So this way we can communicate with customers automatically, even if they're not running the newest, latest release that we've pushed out. Automation is something that's increasingly becoming important for customers. Well, a lot of our customers know and love the UIs. I was talking to a customer recently over in Europe. They had over 1,000 vSAN remote clusters to deploy. They actually built a workflow using the APIs and working with vRealize Automation to where they use vRealize Automation to push button deploy vSAN clusters. It's kind of meta when your application automation platform is starting to automate deployment of infrastructure. This is a fun thing, but we've got great APIs, we've got great cookbooks. Jason McCarty has done some great work, and if you're, we've got the hackathon. It's Monday, right? It's Monday. There we go. Monday night tonight, we actually have the hackathon going on. I believe that's at the Luxor. There's some teams, they're gonna be doing things like automating an entire vSAN stretch cluster deployment from scratch. There's one team that they're doing a deployment of vSAN encryption and automating the deployment of the key management server, I believe high trust they're using, and the establishment of that trust in the peers and keying. So it's gonna be kind of a fun, nerdy alternative to some of the parties if you're looking to hang out with the automation kids. I know William Lamb and Alan Arnouth will be there, but there's some great examples. So if you've got questions on automation and things like that, reach out, look at the resources within the developer community. Also the VMware code team, they have a Slack team. That's a great place to reach out. There's a lot of guys who are obsessed with automation there that can help you. So deploying vSAN, if you're setting up vSAN for your first time, previously kind of had a chicken egg problem if you had no storage in your environment. You want to use vCenter to add it and set up and uncheck that box and turn on the host, but if there's nowhere to deploy vCenter, what do? Now we had a supported method of bootstrapping a one node vSAN cluster, but it required going to the CLI. There's a little more work and it was not necessarily as polished as it needed to be. Now when you're deploying your vCenter server appliance, you actually get a wizard directed workflow and you can say, I want to, on this host I'm deploying it to, set up vSAN. So it'll establish a one node vSAN, deploy itself on top of it, and then you can go add your other hosts. Note a one node vSAN is not something you should be running continuously. It's not a long-term support solution, but this will get you to that point that you can add the other hosts, establish your full cluster, and get ready to run. This is part of that just basic workflow. And we're looking at every step of the operations from the day 2 operations and improvement there, but also just how quickly you can get set up. We sat down with some of our friends with professional services and said, okay, how long is this taking you to install, and where can we cut time out? And there were a lot of cases where it's do this step, wait on this thing, and by having all of that, where you pre-set up all that information, you mash enter, yell YOLO, and wander off, go find a sandwich, and come back. You've got your vCenter and your host, and you're ready to add the rest, build the rest of the cluster. This helps a lot. One thing I will note with the vCenter server appliance, anyone using Windows vCenter server? Shame upon your house. So my understanding is the next release is the last one, and even then it's deprecated. Please get off of it. You can't, vCenter server HA requires it, and the Photon team did an amazing job on 6.5 when they ported. They got off of the SUSE that we previously used. It is really fast. It reboots really fast, operations. They did a lot of great stuff in terms of just forcing Linux best practices, logs go to /var log, just a lot of the any previous issues you may have had, with the old VCSA, the 5.0, it's come a long way, I'll say that. So I was a customer, I used it from the very beginning, and it's ready for prime time in that regard. It's got an integrated vPostgres server. Check that out. Ahmad Yunus has got some great sessions on it. So we've got our one node vSAN, we've got our VCSA, we've added some other hosts, but we got to still do some work, right? We've got to set up vSAN networking. We also have other things that aren't necessarily vSAN related, but we need them set up. We need vMotion set up. We need to configure a virtual distributed switch. We need to turn on HA and DRS. You would be shocked how many people forget to check that box. I totally never did that. Maybe once. So, but there's a lot of little things doing to setting up a cluster. And again, working with friends who work in professional services, looking at those workflows, we said, how can we streamline and make this better? This is really the first step of it. It's called Configuration Assistant. So what this does, this takes the concept of health check. Let's look at your environment, see if there's anything there. But it's great if you do that and provide you some information. But now it's a guided remediation. There's actually a button you can push that says, I want to fix this. HA is not on, take me to the checkbox for it. I want to set up vMotion. I want to set up the vSAN VM kernel ports. How many of you have set up a large cluster in a UI, clicking next 1 million times to set up VM kernel ports? What is it, like 8 clicks per VM kernel port? Do that twice per host for vSAN and vMotion. Multiply that times how many hosts. That's an afternoon of a lot of clicking and typing. And another benefit for automation, it's not always about time saving, it's about consistency. So you know what the largest source of downtime in your environment is? This guy. It's humans. Lack of consistency. breeds inconsistency in environments, and that's where eventually you have issues and potential outages and problems. And so we now have the ability to where when you're setting up your VM kernel ports using config assist, select all the hosts you want to put VM kernel ports on. You'll get a list of all the IP addresses and subnets. Enter that first one, put your subnet mask in, put your IP address. So let's say you do 10.1.1.1. It will go through and just sequentially fill them out. .2, the last octet will just change and push enter, and you're done. You don't have to go click 16 times and type 2, subnet mask and an IP address, 64 times or something. So it's little things like this that really will help get that environment up quickly, but also get it up consistently. Another thing to note with Config Assistant is also a brownfield remediation tool. So let's say someone, deletes the wrong VM kernel port and takes out the vSAN VM kernel port. It's not a fun thing to do on a host, but you'll get an alarm that says this host is missing a vSAN VM kernel port. Do you want to set it up? It'll direct you to remediate issues that have arisen in an environment. So it's easy to make tools that automate things in a perfect world. It's hard to make tools that can cleanly work in a post-install environment day 2. Maybe a whole new team has shown up. They have no clue this stuff was set up. And that's something that we're trying to make better in terms of that workflow. Another great feature of Config Assist, how many of you love figuring out driver and firmware levels for RAID controllers and HBAs? That guy. All right, he must be a network admin because he's kind of weird. So to help with this, we've got 4 launch partners. We're bringing on more. This is the initial rollout was Dell, Lenovo, Fujitsu, and Supermicro. On your controller, we're going to identify that on the vSAN HCL. We're going to phone home and actually be able to pull down from those vendors the drivers and firmwares. And you push a button and say, I want to remediate this cluster. If DRS is set, it's going to roll through the cluster, move VMs back and forth, patch those, get those to where you need. Because this is one of those things, like at one point in our life cycle, I think half of our support tickets were related to controllers back in the day. We've come a long way working with our hardware partners, and they're joint partners. We both commit to supporting our customers in this regard. But making this stuff, making life cycle easy, this is critical. Again, going back to availability. Availability is not something you buy. It's not a magic box that produces 7 nines. You want to get past 3 nines in your environment, it's about improving your operations, making your operations easier, making it to where you have fewer people doing things manually and making opportunity for mistakes. And little pieces like this, it's part of how we view HCI holistically, and vSAN delivering that as a solution is making this stuff easier. The other piece is the concept of, I mentioned those HCLs and things like that, and it's figuring out, all right, I've got these hosts, where can I go? What can I update to? Got the vSAN HCL I got to consider for my devices. I also have just the vSphere HCL. Is 6.0 even supported on these ancient hosts? Things like that. So VMware Update Manager is a great platform. I used to love just mashing remediate all and wandering off to lunch. It'll go through and update your host and deliver patches. But we now have, with 6.6.1, we've actually injected the baselines for vSAN in that, so it will opportunistically go through and find the lowest common denominator of where you can go in terms of patch level. So, and make sure that the right drivers get loaded. You don't start deploying drivers that haven't been certified yet and things like that. So this is a great tool. We're looking to extend this even further. This is part, again, of, and it's fun because people say sometimes they'll tell me, this isn't a vSAN thing. I'm like, well, it's not, but holistically, vSAN's baked. It's a feature of ESXi at the end of the day. It's baked in the kernel. Everyone has vSAN, whether they've turned it on or not. The code's there, just may not have licensed or configured it. So we have to, improve the supportability of the platform in order to keep expanding our footprint. So health monitoring. We've made these improvements, as we've discussed, on the health monitoring, but we also have got to keep making additional improvements in this. And this team has been tightening up the quality of this. By the way, if you want to suppress a health alert, maybe you've got a known issue, there's some other things, or engineering is giving you custom guidance against something, you can actually go through and suppress them now. But also, previously we didn't always clean up duplicates. After a cleanup, again, going back to the older versions, we were just trying to rush something out to get something to help customers identify issues. Now that's a lot better managed. Alarm fatigue is a huge risk in production environments. We've taken aware of that, and we've listened to your feedback. We really do. And so that's where a lot of these improvements have. Anyone using HP Gen 9s? We've got a lot. If you ever, we've The storage device serviceability, that improvements mentioned, there were some issues with some of the controllers blinking drive lights. It sounds small, but it's a huge deal. You gotta make sure you're replacing the right drives and things like that. So we've worked with HP on that. Look at the new driver and firmware updates. We've got that capability in. So performance monitoring in your environment. The vSAN performance service was introduced back in vSphere or vSAN 6.2. And while we do have VROPS and other things that I'll talk to, the performance service is native, and there's some cool things about it. So first off, remember how I mentioned we love vCenter, we use it as a management tool, but at the end of the day, vSAN is standalone and a lot of underlying components and survivability. That includes the performance service. This database is not stored in the vCenter database. It is written as an object directly against the object store. You actually can set a policy. The maximum capacity it will use when you turn it on is 255 gigabytes. So just be aware of that in your sizing. Everyone should turn this on. It gives you so much visibility. So we've got a top-down visibility. I can select a virtual machine and say, all right, what are the I/O characteristics it's generating? What latency is it seeing? So I've got that top-down visibility, but I also have a bottom-up visibility. So I can drag it into hosts. I can drag into individual disks and say, what is this disk's queue length? How many commands are queued? What is the raw latency? So we really have an end-to-end visibility. We've also added, with vSAN 6.6, the ability to look at network statistics here. So we want to have it to where you can quickly go through all the key metrics that impact you. So if you've got packet loss in your environment, storage networks in general, not just vSAN, really do not like packet loss. So you can see that, and you're going to see, you get alarms and directed to that. So we've also added statistics for iSCSI in this environment. We're also added statistics for resynchronization and client cache. Now, client cache is a fun feature. It was introduced in 6.2. This is a data locality-based DRAM cache. There's a local memory cache. It's 1 gigabyte on each host. And what that is the reason why it's local is because memory has very low latency. It's actually lower than a network. Flash devices, they're actually often higher than networks. So the network isn't a huge latency impact, but on memory it is. This is incredibly fast what memory can deliver. And so if you've got often environments like VDI and things like that, so a base replica, Windows that's booting for a virtual desktop, it's about 350 megabytes. That's all that's accessed. Now it'll burst 800 IOPS on that boot cycle, but it's a very small amount of data. And so being able to have that type of data, particularly if you've got a replica on a base VDI image that can sit in RAM locally on the host, the best I/O is the one that never actually hits the back-end storage system. So it's a small feature, but you can actually look at the cache statistics now within the performance service on that. It's an odd question, but sometimes people ask me, they're like, I'm generating all this, I'm seeing all this performance, but I don't even see the back-end load. Well, it's getting redirected to local memory. It's kind of nice. Cloud connected performance diagnostics. So with vSAN 6.6.1, there's a new section called performance diagnostics. Now the initial release on this is focused on benchmarking. We've got grandiose plans, I promise. Things will happen potentially in the future. But the initial focus is on improving benchmarking and testing of configurations. So one thing I've learned from working with POC and benchmarking teams is, and just my own previous experience as a consultant, is most people really don't know how to do a benchmarking properly. There's a lot of just bad methodologies out there. Very often people create one VM with one VMDK and get some crystal disk or something meant for testing a desktop hard drive. And they'll run that and they'll say, well, here's my results. You know, it reminds me of, I had a meme I was tweeting out. It's, you know, SAN people, they hide behind single I/O workloads. But the reality is in an HCI environment, you've got multiple VMs generating multiple workloads simultaneously, and how the contention of that's handled across the backend is much more an indicative discussion. So for this reason, we built a benchmarking tool called HCI Bench. But fundamentally, HCI Bench is a very flexible platform. I could say I want 100 VMs doing 10 threads, doing large block writes, or 2 VMs doing light reads. It's highly tunable. And so people are trying to see, how do I test the capabilities of IOPS, the amount of in-out operations per second? How do I test the capabilities of throughput? How do I test, look at latency under load? And so what you can do here is you run a benchmark. Say you're running a benchmark for throughput. And you'll run this benchmark, and you generate a given workload in HCI Bench. And you put it into performance diagnostics. It's going to phone it home using the CEIP, Customer Experience Improvement Program. That data is anonymized, sent back. Our cloud will analyze it, and we will return to you a recommendation specific to your environment. So maybe you're trying to test throughput, but you've got a single VM that's doing small amount of I/O generation, and there's no stripe policy. We're going to say, look, you're not hitting all the backend disks. Here's a KB, direct some recommendations and configuration changes. You go change that. Then it's going to show you how to get, so to speak, that more impressive number you're looking for, as well as know really where the more scalability of what that platform realistically can do when you start generating multiple workloads and things like that. So this also, if you're running HCI bench, whenever you're on a benchmark time frame, while you can take performance diagnostics and target specific time frames, it'll also automatically populate when that HCI bench run was there. So you just hit the drop down, it's very quick. Visualize operations. So if you haven't looked at this in a while, this is the new interface, the Clarity based. It's running HTML5. It's very pretty. It's a term I like to use. So this is a great tool. While we've got vSAN, the performance database, it's really more around tactical, immediate discussions, that existing cluster. What happens when I have 100 clusters? Well, we're going to roll up aggregate cluster stats. So we're going to look for that data that's been rolled up in here. And on the left, we can actually select and drill down. We've got a specific cluster targeted. And from here, we can actually look at cluster-specific statistics. So that way, we can start drilling down to specific outliers and things like that. This is fully integrated into vRealize Operations 6.6. We've got several dashboards that are actually in the standard edition, as well as there are some more advanced dashboards that are in the advanced licensed tier with that. So, but the other thing is, particularly if you've got advanced and you've got the storage pack loaded, this also lets you use this same tool to also monitor existing storage arrays, other things, as well as VROps also has great content packs for like Horizon, VDI, being able to analyze for desktop environments, PC over IP statistics. So if there's a performance problem in an environment, you've got a user, a VDI user who's calling you and saying, hey, I'm having a problem. You can look all the way down to the individual storage device in vSAN, and then at the far end of the spectrum, go all the way and say, well, I see high packet loss on your PC over IP connection. I see your remote user. Looks like you just have a bad internet connection at home. So giving your operation teams that end-to-end visibility is incredible. Because historically, this often would have been a number of phone calls and finger pointing between 3 or 4 different teams to try to figure out where the actual issue was. And VROps, because it rolls up information and it's designed to hold that information for a very long period of time, maybe it's 2 weeks later, you get asked about an event, you actually can go back and drill back and look for the true root cause of that environment and have that visibility of this workload or this desktop had all of these various things feeding into it, and here's what was red, here's what was hot. So a lot of work has been done specifically on the vSAN packs to redesign this. Some guys who work heavily in operations have consulted on this, so please go check those out. So we've got some new improvements in the environments. Oh, one other thing on the VROps, we also have a great Log Insight pack. Anyone got Log Insight deployed? Okay, everyone go home and deploy Log Insight. Don't use our, seriously, go deploy it. It should be used, in fact, if you're running vSAN, vRealize Automation without Log Insight, I don't even know how you survive, because it is just an amazing visibility and understanding of capabilities in the underlying platform. So this is a log aggregation product. It works with vRealize Operations there, and that it will take those log events and correlate them to the performance data and inject it. So it's one thing to know I've got high CPU or I've got high latency. Is this good? Is this bad? Why is this happening? Maybe it's just a lot of workload. Maybe this is normal. Who knows? But being able to take those events and say, oh, we've got multiple disk failures or various things like that, inject those, or maybe we've got, maybe someone's doing a huge Tomcat workload. Being able to have those different dashboards at the application infrastructure level and pull those together, that actually gives you context for that resource consumption data. So the vSAN performance improvements, there's a white paper, again, go out to storagehub.vmware.com. It's a source of a huge amount of vSAN information, data, walkthroughs, and so forth. We made some significant improvements to the overhead of checksum. That cache has been, the behavior of the cache has been significantly improved. And so if you're using the checksum, which is enabled by default, this is going to reduce I/O amplification significantly. The other one is the deduplication compression. How the destaging is done on the back end, we're significantly reducing CPU overhead associated with that and reducing bottlenecks on sustained write workloads. We've also made improvements in terms of write compaction, how we do writes. In some cases I've seen, I hate saying percentages because then everyone says, well, my workload doesn't do that, but I've seen 50%. in some cases for some workloads. So this can be a pretty big deal. So this is another reason, this part of the fun of vSAN is, we're constantly releasing new improvements. We're learning from customers, we're learning from environments how to make the product better. iSCSI has been updated. Another thing is, while we previously on sizing guides, particularly on hybrid, we kind of had the 10% rule of thumb on cache to capacity consumption ratios. For all flash, we've actually improved our guidance. We've changed it. It's no longer based on an endurance or a capacity model, because as people start putting 80 terabytes of flash in a host, it starts getting kind of silly having 8 terabytes of cache running that. It's actually shifted, and the endurance of these new devices are so high. What we've done testing is actually we're designing around performance. And so if you go to the vSAN design and sizing guide at Storage Hub, or you go to, there's a blog about the new cache guidelines, you'll actually see that it's based around a performance. So you basically can dial your performance. I have a high write workload, medium or low, and then I want to generate X amount of 4K IOPS in terms of that profile. And you'll say the most extreme recommendation or the highest in terms of general benefit is 1.6 terabytes per host. Another thing also for performance sizing to remember, more disk groups is better. Try to start with 2 if you've got a pretty performant environment. It helps with extra parallelization of I/O, as well as also it provides more areas for rebuilds, because if you lose a cache device, you'll lose that disk group. So that actually helps with internal resiliency, provide more options for balancing data. There's also a new vSAN Ready Node Sizer. There's new capabilities. That tool has been completely rewritten from the ground up. There's actually a fun thing with it. You can actually say, show me the math, and it'll actually explain the maths behind its recommendation. So you can understand some of our internal overheads and things like that. We've had day 0 support for the new Intel processors. We've also got some new support for hardware platforms, HP Apollo, HP Synergy. They're in the HCI zone. This is really cool hardware you should check out. Also, there's a new persistent class of memory. So 3D Crosspoint, it's been jointly engineered by Intel and Micron. This stuff is really fast. And we had day 0 support. We saw significant performance improvements. This is something for those of you looking on the more extreme end of the performance, start looking at this stuff. It's pretty cool. So from an application guidance and things like that, we've also released some new reference architectures. While we already have plenty of reference architectures for your traditional boring SQL, Exchange, yada yada, Oracle, and so forth, HammerDB, we're also getting a lot of requests around next generation applications. People are deploying container workloads on vSAN. People are deploying NoSQL, Splunk, Cassandra, things like that. And so we've been releasing reference architectures, and the team who do this, they're incredibly technical. I mean, these guys go lock themselves in caves for months at a time, then come out with these beautiful, incredibly long tomes with very detailed guidance and things like that. These are not marketing white sheet documents. These are very deep. You can find these on storagehub.vmware.com, which I keep saying that over and over again. Other thing, while you're there, check out the Virtually Speaking podcast. Anyone listen? Do we have any listeners? Hey, we got a couple. Fancy. We just had Michael Dell, just interviewed him an hour ago. He'll be one of our guests this week. It's a podcast myself and Pete Fletcher do, and we cover storage and availability with VMware, so we focus on that. There's some great content on vSAN. We just had a great episode on stretch clusters. So if you're looking for something to do, or you got 20 minutes, you're stuck in a commute, it's a great way to learn some more about vSAN. Before we get to questions here, just last things. We've got assessments going on, vSAN assessments. If you want to know more about what you should do, check out the hands-on labs. Check out the HCI Zone booth. We'll be over there, and then those resources. So at this point, let's open the floor for questions. Anyone have any questions? Hands? No?
Ethernet flow control, is that do or don't with vSAN 6.6? I know that there was a lot of churn with it.
Yeah, so the question is about Ethernet flow control. Honestly, I would just leave it alone. So previously, flow control was necessary in iSCSI networks, and that was because iSCSI would do microbursts. It was very bursty. vSAN's not, actually. And I didn't believe engineering when they said this when I worked for a partner, so I actually wrote my own white paper. It predates me working at VMware, where I tested like 8 different switches, including just some ancient garbage, like a Cisco 3560 that time had forgotten. And no, it's not microbursty, so it's actually pretty cool. The other thing about flow control is it was because switches often had a very low packets per second rating. Like you go back to, again, 3560s, it was like 1.2 million packets per second. Now I have stuff at my house that's 80 times faster than that. So if you're deploying any modern Trident 2 based ASIC 10 gig switch, it's gonna do like 1.2 trillion. So we're actually a lot less worried about microbursts. The buffers can, stuff's not getting caught in buffers because just the raw backend ASICs can process data. So I talked to Potty about that. We had a recommendation about disabling it, but that dated back to old 1 gig switches. Really, if we're looking at it testing on modern switches, it doesn't really impact anything. So that actually was dropped on the newest generation of the networking guide. So.
Well, they actually recommended it for us with Nexus 5670.
Yeah, Nexus 5Ks are weird. They have, we're recorded. They have interesting buffers, I'll say that.
Yeah.
So with, now you just support all flash, and if you lose a flash cache drive, you're going on an entire disk group.
Correct.
Still going down the path of flash cache.
So the question is with all flash, if you lose a flash device, you lose the disk group. So that is true in the case of all flash with deduplication compression turned on. And to understand why that happens is it's because we can't control where duplicate data happens. So data is actually striped automatically within a disk group because we can't control where the pattern matches is. It's not like normal vSAN where the object is going to be just on these capacity devices. So there's basically like it's almost like a RAID 0 stripe effect, and it actually gains some performance to help offset the overheads of dedup. No, the key store gets, well, first off, it's cached in memory, but that's a cache, obviously, so it ends up on the capacity tier. But, and actually, I think in one of the recent versions, we may have written a copy down to the flash device, generally because it gets better latency. That actually something I may have to look at where that moved to. But fundamentally, you still get that behavior with dedupe compression, but it's fundamentally tied just to how dedupe works. Once patterns start matching, because otherwise your dedupe domain would be a single disk, which would be really small and not as effective. So for the dedupe domain to be the whole disk group, as soon as a pattern matched, it gets written there. So from that perspective, you do have that behavior. Now, one thing to note is flash devices don't die that often. They really don't. If they do, it's typically actually you've got firmware issues or something. So I mean, with flash devices, they tend to be, I'm trying to remember the term that someone used for this that was rather clever. They tend to have a high, infant mortality rate, or they tend to be immortal. It goes, infant mortality or immortality. So they either die very young, or they run until the end of time.
Other SDS don't have that limitation, and they may use that as a weapon against vSAN. So I'm just curious.
Well, so it's such a corner case, like the failure, those failure scenarios. The other thing is the rebuilds on vSAN. So other platforms, oftentimes they'll take a wide stripe everything approach, which we don't. And so from resiliency, to talk about what vSAN does, it's kind of unique here, is that the reason why we don't wide stripe everywhere is, so let's say I've got a failure to tolerate of 1, and I have 2 devices fail randomly in a cluster. Now, some things might have ended up having both copies on those both. But statistically speaking, the larger a cluster gets, the odds of you hitting both copies gets really low. It's like if I take a knife and I punch it through a phone book, the odds that I actually impacted, a given record that you're looking for are very low. Inversely, if I take a phone book and I rip out a bunch of pages, it's a completely different story. So if you look at how those wide stripe architectures work, let's say they only mirror once. If you hit 2 random devices, you have a 100% chance of losing all data. And in that case, you're now doing a full restore of maybe 100 terabytes versus with our design, if you punch, maybe you hit, so you've got let's say you've got a 10 node cluster, you've got maybe a 4% chance of a given VM being impacted. Now you only have to restore 4% of your data from backup or fail over 4% to DR, as opposed to, this is a huge gap in availability that everyone's not paying attention to, is their time to restore data. Because people are often dumping these things to these magic dedupe appliances. Data goes in very fast, but it comes out very slow. And this is one thing when you're planning your availability and design, I recommend for your DR site looking at all flash. And the reason why is I've seen multiple cases with customers who had traditional hybrid arrays or hybrid storage systems. And hybrid, great architecture, it's not going away, but it's increasingly making less sense because what happens is you try to do a boot swarm of 800 VMs, And on that hybrid system, the data you need for the boot storm is all those little boot volumes. That data is ice cold. It's sitting on those slow drives. Now you're sitting at 10 hours to boot all those VMs because of that storm versus an all-flash environment. GS, one of our peers, I think it was 15 minutes to boot 1,000 VMs on an SRM test recently, just on 4 nodes. So make sure you've got that data replicated obviously elsewhere. Use SRM, use vSphere replication. But also note, the larger your vSAN cluster gets, the impact scale of more failures than you actually even engineered your FTT for actually gets exponentially smaller the larger the cluster gets. And so from a resiliency design, yes, there is that whole, I lose a couple of devices here, but you're not gonna have 2 copies of data on there. The data is always replicated in another fault domain, so. From a time rebuild, so the other thing with how vSAN does rebuilds is the rebuilds actually get exponentially faster the larger a cluster gets. Because again, as we talk about that pseudo-random distribution of where that other mirror is, so let's say I lose 1 device, and I personally, yeah, a whole disk group, but, and this is something you should actually size your rebuild performance, and if you're worried about rebuilds, what happens when a host fails? That's the same for everyone. So really, you should be worried on your rebuild scaling times of what happens if I lose a whole host. Because that's actually something that's, a motherboard's actually, in my opinion, more likely to fry out than an individual flash device. Just I mean, I see MTB failures from our GSS stats, so it's fun sometimes talking to people and vendors.
Could you talk a little bit about space reclamation? No longer using it on there.
So space reclamation, so traditionally with VMFS, you had this fun situation of you write a VMDK, you write LBAs, you write data, and then you delete that VMDK, and the storage array on the back end isn't aware of this, and it was fun. You had a technology called SCSI Unmap, which we released in 5.0 originally, if you remember that. Apparently none of the storage vendors QA'd that. It was, yeah, you had storage, you know, a huge amount of delete commands would just flood controllers and cause mayhem. That feature was pulled very quickly. We released it asynchronously, a different implementation, although the adoption of vendors was kind of all over the board, as well as it's a manual process, which no one likes manual processes, I get it. So vSAN, we don't have that initial problem of space reclamation at the virtual machine level, because when you delete a VMDK, it's punched out of the object store. It's not like the file system is very aware. It's like it's like deleting something on NFS at that point. You've deleted a file. Yeah, we know we can reclaim those blocks immediately. Now the holy grail of space reclamation, the next layer of that is I've written a file inside of a guest and I delete that file and I want to reclaim that file. So the question is, how do you go about doing that? And that requires punching SCSI unmap or trim commands to the back end. So today we don't support that yet, but that's something we're very interested in. Not for vSAN specifically. So it is, yeah. So it is supported against VMFS today. vSAN does not have that yet. Typically, you'll notice though, that some of those things involve core storage. They'll often roll into VMFS and then the vSAN soon. So watch this space. The other thing also is if you do need to do that reclaim today, I know this isn't the nicest thing to do, but if you're using dedupe compression, write zeros. SDelete DD equals 0, out a bunch of LBAs. Dedupe engine is going to scan those inline, so, or as inline as they destage from the cache tier. So if you need to do that, that'll work. Long term, yeah, we're working out. The main thing with that is actually, to explain kind of the engineering behind it, writing the code for that's not hard, it's the QE, because anytime you're punching data out, you want to make sure we really, really don't cause problems, and particularly because of how burned everyone was in 5.0, we want to make sure that's something that, data integrity is more important than anything else, so we're working on that. So on the back end, we're actually using the vendor. We'll actually pull down the vendor tools, and if it's an air-gapped environment, you can actually manually upload the PERC CLI or LSI control. Those are all LSI based, so it's that CLI tool. You can manually upload it, and we'll direct you where to go to download it from your vendor. Alternatively, we'll pull it down. There's actually a way to do that. So. Yeah. We're not using the out-of-band yet. I like making cryptic statements like that. What? VUM will manage drivers. It doesn't manage firmware is the problem. So the config assist will cover the firmware piece. Question?
Yeah,
Oh, so you gotta ask that, don't you? So today, snapshots are not supported. vSphere replication is not supported. iSCSI is really meant for it's meant for some corner use cases. I've got this old physical server that time forgotten that's got some weird proprietary card. I need to give it some data. Bare metal Oracle clusters, just because some people are more scared of Larry's, pirate yachts of license ninjas or whatever. By the way, if you're running Oracle on vSAN, you can do rack on vSAN without needing iSCSI. You can use the shared writer driver. And also, we've got a great blog post out there on licensing on Oracle on vSAN. You do not need to license the whole cluster. Yes, there's a full reference architecture built by the PE team with performance information. And that's on storagehub.vmware.com. Hold on, sorry, it's hard to hear. So is the kernel process single-threaded for writes? So there's a lot of different processes going on. Some obviously not. It's not a monolithic thing. This isn't like Flare back in the day where like every single logic is running in one thread. So there are a lot of threads running. There are some processes that are multi-threaded for different things. There's some things that are single-threaded. One example where we've changed that was the log replays, when you rebooted a host, we go through and replay the entire log of the cache and any pending data. That previously was single-threaded on a host, and that's why it could take a while to reboot a host. It's either 6.5 or 6.6, we changed that to be multi-threaded. We're continually looking for more ways to do parallelization across the back end. There are some things that obviously will be more just the nature of computer science. There's some things that are still harder and that's still waiting and pending. And so if you're really trying to push the extremes of performance, do pay some attention to your clock speed. So if you've got 1.8 gigahertz you're gonna, low wattage processors, do not expect do not expect to push 150,000 IOPS per host. I'll say that much. So, question? No. Question is about RDMA, raw device memory access. So I would encourage you, as if you're refreshing your switching, because people like to do this like once every decade epoch, do pay attention to make sure your switches will support RDMA. RCOE is going to be kind of one of the next major standards in terms of that. Seems to be a lot of stuff congealing around that. Do pay attention to that. Also pay attention to that on NICs as you're doing your refresh, because that's another component where RDMA to work, you have to have NICs as well as to have that. Do we support it today? No. Am I going to make comments about future products and things like that in a public forum? No. But it's something just to keep options open. I always recommend. That's actually just some general guidance I can give you. Yes? Support for TCP. Oh, data center bridging? No, data center bridging is a technology everyone away from. In fact, Intel is dropping support for it on their NICs. So like my other favorite protocol, fiber channel over Ethernet, which fiber channel over token ring makes more sense than, let's be honest. Intel is dropping support. You are no longer supported running FCOE on an Intel NIC in 6.6. So it's dead gem. It's dying. Yeah, so. DCB was a critical component. It basically made Ethernet look lossless like fiber channel. And again, if we're gonna make networks try to act like do unnatural ways, we might as well just roll back to token ring. That was a much more civilized time. So, question?
Any success stories or use cases that justify using
3D Crosspoint. So 3D Crosspoint. First off, we did have day zero support. It is out there. Obviously, there's not that many people have hands on it because of what it requires in terms of CPU and things like that. I personally don't have any, specific use case. Expected obnoxious though amount of marketing out of our product marketing division once we start getting public references lined up with that, because that stuff is cool. One of the benefits of 3D Crosspoint in general and NVMe is it's not just that the devices are faster, but it lowers CPU consumption. There's a hell of a lot fewer interrupts involved in getting I/O in and out of those damn devices. So. Can it push more IOPS? Fine, but it's kind of like just pushing more raw horsepower. If I've got 1 million horsepower but it's on a tractor, it's not as useful as it is on a motorcycle. So by reducing CPU consumption, we give more CPU back to you, because we could build the fastest storage array. We could build something that does 2 million IOPS per host. It also would leave you with 2% of the CPU left to actually run a workload. it's not very purposeful. One of the overriding design considerations of vSAN is leave plenty of compute left to actually run workloads. I've seen HCI systems out there, I won't name names, where I've actually seen cases where half of the compute was going to the backend storage stuff. And if you're paying what you guys pay to Larry and his pirate yachts for Oracle licensing, and you're paying for a core and basically only get to use half of it, I mean that's pretty bad. So we're trying to keep CPU usage down. Obviously NVMe and 3D XPoint, they help do that. Some next generation technologies that might at some point, like RDMA, that's a pathway in the future. We're always looking for new ways to do more with less. So, all right, I think we're gonna get kicked out of here. So,
Excellent.
thank you guys.